Welcome to this class on physics. The topic is current electricity and it is the continuation of last class. When in the class, I am going to discuss on temperature dependence of resistivity, electrical energy and power, and cell EMF and internal resistance. So if you do not have the concept on this, after this I am going to solve the problem on it. You will find it difficult to solve the problem. So first of all, temperature dependence of resistivity. You know resistivity is rho. I have explained in the last class. So where I have written the resistivity of a material is found to be dependent upon the temperature. However, all the materials does not show the same type of the variation, either increase or decrease of resistivity with temperature does not show the same type of variation, and it depends upon the type of the materials. However, the normal relation of resistive dependence of resistivity with the different material is rho t is equal to rho naught equal to 1 plus alpha into 1 minus t naught, where rho t is equal to resistance at certain temperature and rho naught is resisted at zero temperature, resistivity at zero temperature, and alpha is the temperature coefficient. So in due course of time we will explain how the resistivity varies with different temperature. Now I have divided into three parts. The temperature dependence of resistivity materials, three types of materials. One is wire bound resistors, other is semiconductor, insulator, other is metals. So wire bound resistors are two types. One is carbon type of resistors and other is alloys, resistor made of alloys. So resistor made of alloys, so in the first part I have written here the wire bond resistors are generally made of alloys, and alloys are the some examples of alloys are manganese and constantine and nichrome. Manganese are the nothing but the alloys of the metals copper, nickel and manganese, and constantine is the alloys of copper and nickel, and nichrome is the nickel, copper and chromium. To discuss about the variation of resistivity with temperature in wire bond resistors, which are nothing but the alloys, nichrome, constantine and the manganese, we see there is a little variation of resistance with temperature. So we will not discuss about these things. These alloys have a very little variations of resistivity with temperature. Now let us come to the semiconductor of insulators. So to explain this one, in the last class I have already mentioned that rho is the resistivity and sigma is the conductivity, and rho means resistivity is equal to inversely proportional to the conductivity. So rho is equal to 1 by sigma, and also I have written the expression that is equal to n that is equal to m by n square tau. When m equal to mass of the electron, n is equal to number of the free electron equal to charge, and sigma is tau. Tau is the average time or relaxation time. So here let me explain a bit back. In my last class I have told you what is relaxation time. It is the average time between two consecutive collisions of the electron after collision or before collision. We know in a conductor when electron moves, so during its velocity, during its motions, there is a collision with the fixed ions, cations. So during this collision they scattered in different directions, and due to this one come from this place to this place, and between two successive collision the time requirement is called tau. So we have seen here resistivity is inversely proportional to tau and inversely proportional to n, means number of electron, free electron, if this more, then resistivity is less, and if tau means successive collision or average time is less, then resistivity is more. It is quite implied from the expression. Now let us first of all understand semiconductor insulators. What happens in these two cases on increasing temperature? So what I have written, let me explain that in the semiconductor or insulators, when we increase the temperature, the number of the free electron increases. Two things happens. Now, with the increase of temperature, number of free electron in the materials like semiconductor or insulators increases. And on the other hand, when the temperature is increased in semiconductor of insulators, so the velocity or motion of the electron increases. And when they collides, and during the collision between the two successive collision, the average time decreases because it speedily collide to one another, speedily comes out. So between these two, the time lapse is small when it moves faster and faster. So as increase of temperature, the tau relaxation time or the average time is decreases. The two successive collision time decreases as electron starts moving faster with increased temperature. So two factors come into play. One is number of n increases, electron increases, means this increases. When this increases, other thing remaining constant, now resistivity decreases. But on the other hand, the simultaneous thing is that on increase of temperature, relaxation time decreases. And if you don't assume this one, so we see rho is inversely proportional to tau. If tau is less, reaction time is less, means resistivity increases. So with the increase of n, resistivity decreases, and with the decrease of tau, resistivity increases. So two things come into play, but the increased number of free electron compensate the decreased value of the tau, means finally it becomes increased in number of free electron. So if it compensate the decrease, so number of n electron with increase of number of free electron, the denominator is going to be bigger and bigger, means rho is smaller, means the resistivity decreases with rising temperature in case of semiconductor and insulators. So rho is equal to 1 by sigma is equal to m square tau. But for metals, what's happened? Without writing anything, just let me explain it. For metals, the number of the free electron doesn't have any influence upon the rise of temperature. So this remain constant. For metal, so what's happened here actually? For metal, number of the free electron is independent of rise in temperature. So if you increase the temperature, there is no increase in the number of the free electron. So this factor is not playing any role. And now come to the tau. So as earlier we have explained, when you increase the temperature, the relaxation time of the average time tau is decreased. So with decreased value of tau, denominator is decreased, means whole value is increased, so resistivity increases. So for metals, the resistivity increases with a rise in temperature. Now let us define what is power and what are the different form of power from mathematical point of view. We know Wt is equal to IV del T, and where I equal to current and V is the voltage potential difference, and del T is the time lapse or difference in the time, and this is work. Again we know work is the energy, so energy is equal to IV into del T. So we can write Del W divided by del T is equal to IB. From this we have arranged. So this is nothing but energy divided by time, rate of energy, or energy dissipated. Energy dissipated per unit time. Energy dissipated per unit time is equal to IB. And according to definition, energy dissipated per unit time equal to energy power. Therefore, del W by del T is equal to power. That is power equal to IB. So from Ohm's law, we know V is equal to IR. So I is equal to IR equal to I square C. Again, V is equal to IR. The I is equal to V by R. So in place of I full plate V by R, we are getting V square by R. So for power, we are getting different relation. P is equal to IB, P is equal to I square R, and equal to P is equal to V square by R. This is in short regarding electrical power and energy. And these terms are very important for uh, um, how to minimize the loss of electrical power during transportation power from powerhouse to our industrial places or home. So what's happened? Power is transmitted from the center from where power is generated, and it is long away from our house or industrial places. So the power has been carried out or transported from power generation place to industrial place or household places. So huge distance is to be covered. So it is seen that there is every possibility of losing power, because power is equal to W by T and W by T is equal to IB. In this way, we see that it is nothing but the energy dissipation per unit time. So energy may be dissipated. Energy may be dissipated. When a bulb burns, so it gives lights, also it gives energy. So there is a loss of energy. So energy dissipated, energy losses. So we see when power is generated in a long distance away from our household places or from the industrial places, there is huge chances of loss of power. So it is required to minimize power. Let us see how power loss can be minimized during power transmission or electrical power transmission. We know power is equal to IB. Let us give it 1. Now we can write from here P is equal to I square R. So P is equal to I square R. We write here PC. Now what is PC and what is RC? RC actually is the finite resistance of conducting wire inside the cable. Am I right? So RC is the finite resistance of the wire connecting to carry the electricity from power station. Am I right? So regarding with RC means resistance of conducting wire to carry current to our household from power station. Wire resistivity is finite resistance, and that resistance out of this resistance, when we calculate I square R into its power, then power C is equal to I square by R. Means power C is the power dissipated, power loss. So from above, if you write I is equal to P by B, so this is equal to P by B whole square into RC. So just to simply put this value of I from here, you put this value into what we get, power loss, power dissipated, power loss is equal to P square by B square into RC, means PC is inversely proportional to B square. Means if we want to minimize the loss of power during the current which is generated in the power station and is transportation to our household places or industry. So we need to do what? That if the potential difference, that voltage, is made higher and higher and higher, there will be lesser and lesser of power loss. That is, B should be higher and higher. That is why a small question very often asked. That is why the wire which carries current, electric power, electric energy from the power stations have very high voltage. Why it is required? So because of this high voltage, loss of power is less. But on the other hand, there is a problem. The problem is that from this high voltage wire, if you just want to use this current in our household industrial purpose, it is not safe. It is very unsafe. So that's why what's where when it is carried out to some place, and from this place when it is placed in the industrial or household place, a transformer used, and that transformer, the working of the transformer is used to minimize the potential difference, to lower the potential difference. That's why it makes the use of the current safe. So let us come to the point cell, EMF and internal resistance. These points are very important in solving of the problem, and instantly I am going to solve out the problem after discussion of the theoretical part. In a very precise manner, I will try to solve this out. Electrolytic cell, you have got in chemistry, I have already explained in second year. In electrolytic cell, that is electrolytic cell or the cell, any cell, is a device used to generate steady electric current in a circuit. These are the source from where current is produced, to steady current is produced in the circuit. So I have represented an electrolyte, any electrolyte. I have given here electrolyte, an electrolytes, and it is diluted into water. An electrolyte, electrodes, one is P and other is N, means cathode and anode. One is positive and other is negative, is introduced or immersed into it. Am I right? So this is the setup, and later on I have just connected a resistance. This is resistor R in the outside of the electrolyte. Now forget about the resistor. So what's happened whenever the electrodes are immersed in the electrolyte, say it is P and this is N. P is the positive in nature, positive, and its potential is B plus, and N is the negative in positive, and its potential is equal to minus V negative. Am I right? So now question appears, why it has got its potential is B plus, it has got some potential, and N has also got some potential, and the magnitude is reverse of each other. The question is how the potential arises. The potential arises because we have not applied any current in it till now. So in absence of current, when electrolyte are when electrodes are immersed in the electrolytes, then there is exchange of charge. The exchange of charge between the electron to the electrolyte causes potentials. The exchange of charge between electrolytes means anode to electrolytes, or electrolytes to anode, vice versa, and electrolytes to N and N to electrolytes. So there is always exchange of charges in between electrodes and electrolytes, and due to this exchange of the charges between electrodes and electrolytes, it causes some potential, and it produces positive potential and is causes negative potential. So now in this time I have given a point A and point B, and I have given you an area from where a potential is developed. In P, the potential is developed in between A to B, where actually in practical sense there is no demarcation of line. Demarcating line is not there. Just I have explained that in some certain area there is potential around P, and the potential around P is PA, and potential around N is NB. It is just an area, no demarcation is required. So it is for understanding. So the potential B plus and minus B negative has been produced due to exchange of the electron in between electrolytes and electrodes. And now what is the difference of potential? Though there is no current, that difference of potential is equal to V positive minus V negative, means V plus and VE, and that difference of potential is called electromotive force, EMF. Though there is no question of any force in the earlier, in traditional manner it was used in force. At that time the experimental factors were not too much clear, hence the term force is apply, though there is no electromotive force, there is no force at all here. So potential difference B plus B naught, B plus B minus is equal to epsilon, and this is in EMF. Now how will you define EMF? Very often you mixed up with EMF and V. Now you distinguish yourself. In absence of current, there is no current. When you define EMF, absence of current. In absence of current, the potential in the electrolyte already developed is uniform throughout. So the potential which is developed in the electrolyte in uniform manner in absence of current is called EMF. Now what's happened? I have just connected in external circuit a resistor R. When resistor R is currented, the current produces, it starts moving. So when R is produced, R is connected in the external circuit, the current moves from C to D. Simultaneously, a steady current is maintained. A steady. So now we are coming to some complicated terms. In absence of this, we get E or epsilon, and that epsilon was termed as EMF. Now when we connected a resistor R, so the current starts and it moves from in this direction, it moves from C to D through the resistor. In resistor R, the current moves from C to D, and instantly what's happened, to maintain the steady current, due to movement of the current from N to P. It comes in this way and passes from N, it goes through P. So outward circuit, there is movement of current from C to D, and when in the electrolyte, the current starts moving N to P, and due to maintenance of steady current. So a steady current is maintained due to the movement of the same current. Whatever the current in the outward circuit is the same current in the electrolyte, and which moves from N to P. Let us understand another fact with this explanation. Now we know V is equal to IR. Now what is I? I is equal to V by R. Now if R is not finite, if R is infinite, so if the R is infinite, V by infinity is equal to 0, that is current is equal to 0. So when this R is infinite, the current is 0, means in the circuit there is no current. So when there is no current, what's happened? The potential difference is equal to, we have already calculated, is equal to this much, and that is equal to epsilon T. Am I right? Now when the current is infinite, resistance is infinite, we see there is no current, and if there is no current, the potential difference is, I have effaced out, yes, the potential difference is the potential difference due to the interaction of the charge, exchange of the charges between the electrode and electrolytes, and this is nothing but V plus V minus. So this is nothing but electromotive force. So potential difference equal to V plus V negative equal to electromotive. This is the electromotive force in the electrolyte. As soon as we connected a external resistor R, and when this R is finite, if it is infinite, then current is 0, and that 0 current, then we get EMF, and that EMF is equal to V plus V minus. Now when R is finite, the value is finite. If it is finite, so there is no question of making this term 0, means current is not 0, means there is current in the circuit. When the current in the circuit, so this current will come to the electrolytes. When the current enters into electrolytes, so in the electrolyte has some resistance. The electrolyte some resistance due in current. When current is passed, electrolyte has some resistance during the passage of the current, and this resistance of electrolyte in presence of current is termed as internal resistance and designated as small r. So what you see, when r is finite, then I is equal to b by r, then this denominator is not infinite. If it is not infinite, it will never be zero. So I is having some value. The current has some value. When this current enters into the electrolytes in the system, so electrolytes have some resistances, and this electrolyte through which current passes has a finite resistance small r is called internal resistance. So the internal resistance is due to the passage of current into the electrolyte. Electrolyte has some resistance, and that resistance is termed as internal resistance. So we write, now what is the potential difference inside the electrolyte? Then potential difference inside the electrolyte is sum of the potential developed in between P and A, potential developed in between A and B, potential developed in between B and N. There are three factors will be sum up. So potential difference between P and A is equal to B plus, I mentioned earlier. Potential developed between B and N is equal to B negative, I have mentioned earlier, and difference of these two potential is equal to, so I have written potential P to A is equal to B A plus, and potential B to N is equal to B negative. And if we bring this to close by close, B2 plus B net, it is the net potential difference between these two electrolytes. Now the gap inside the gap in between these two is nothing but electrolyte. What is the potential developed in electrolyte? That is E and B, and this potential is equal to P is equal to B is equal to IR. This is potential. B means IR, and we have assumed that potential in the electrolyte is equal to IR. I is the current and R is the resistance small r, which is termed as the resistance, internal resistance in the electrolytes. So R. So now there is a question why this is minus. So if it is sum, so why it is minus? The minus is because the current is moving from B to A. External current was C to D, and inside the solution or electrolyte, the current is moving from B to A. During the change in direction of the current, that is minus. So we get B is equal to E minus IR. So B is equal to E minus IR, and from Ohm's law, from the outer circuit, we can write B is equal to IR. That R is the resistors or resistance of this, and small r is the resistance in the electrolyte during the motion of during the passage of current into the electrolyte. If you mix up these two, one IR is equal to epsilon minus E by R, or I is equal to E by R plus R, and this is the expression of current with EMF, resistors, and internal resistance. So from this, we can imagine one thing, E is equal to epsilon minus R plus R, that I maximum current will be maximum when R is equal to 0. Current will be maximum when R equal to 0. But this maximum current cannot be obtained from the cell, because for the value of this maximum current, there will be permanent loss of the cell. Hence, the current in the cell is generally less than this maximum value. So let us take an example to solve out the problem. So you have given this setup, and in the question it is told that 6-volt battery has internal resistance 1 ohm, and in this arrangement you are asked to equivalent resistance of the network whole system Number 2, current in each resistor. Current in resistor, this and this, there are 5 resistors. You are on and last point is voltage loss through AB, BC, CD. In between AB, BC and CD, there is what are the total voltage loss. So to find out the equivalent resistance of the network, first of all, it is very simple. You can very easily find out. That is number 1, in between A and B, so these two are in parallel. These are in parallel connection. When parallel connection is there, we see that is 1 by R1 plus 1 by R2, is not it? So in the last class I told you 1 by R1 plus 1 by R2, that is R1 R2, R1 plus R2. Therefore R is equal to R1 R2 by R1 plus R2. So for equivalent resistance, we just will use R1 R2 by R1 plus R2. So if you put this value 4 and 4, put here 4 4 16 and 4 4 8, answer is 2. So the resistance in this is 2. And from B to C, we need not to do anything. This is 1 ohm given. And from C to D, again it is in parallel. One is 12, other is 4. So answer is 12 into 4 divided by 12 plus 4. This is equal to 16. So it will be 12 into 6 divided by 12 plus 6, and that is equal to 4. So we will get 7 ohm. So our first answer is equivalent resistance of the network is 7 ohm. We have got the first one. This is 7 ohm. Now current in each resistance. So if you want to find out the current in each resistors, we need to find out what is the total current. So what are the expression? R plus R. Now what is the potential? It is 16 volt. What is R? R we have calculated, total R is equal to 7. And what is internal resistance? It is given 1 ohm. So we are getting 2 ampere. So we have got current in whole circuit is equal to 2A. Now the fact, you are asked to find out the current in this. Say this is I1, current in this is I2, say this is I3, this is I4, this is I5. Just we have marked it. So let us see, this is twice A. We have already calculated. Now I1, current I1. In last class I told you current in individual resistance which are in parallel connection, parallel combination, is equal to total current into, if you want to find out the current in this one, so resistance of opposite will be in numerator. You write resistance of opposite is here, divided by both the resistance R1 by R2, means 4 plus 4. If you want to find out the current in this resistance, so you write total current divided by resistance of up 1 divided by total resistance. This is the formula. So current, total current is 2, and this is equal to 4 divided by 8. So this is equal to 2, this is equal to 1 is equal to 1. So through resistor, this I1 means 4 pi, it is 1A. So same resistance we need not to calculate. So I2 will also will be 1A. So this part is over. Now come to I3. Now what is I3? So in case of I3, total current, what is total current? Total current is 2 into B is equal to IR. Am I right? So no need. I into 1 is equal to 2 ampere. I4 is equal to total current into, if I want to, I4 means 12, I will write 66 into numerator as numerator. So 6 above and total resistor 12 plus 6. That is, what is I? I is equal to 2. 2 into 6 by 12 plus 6 is equal to 2 into 6 divided by 18 equal to 3. 2 by 3 ampere. Now what is current in I5? Current in I5 equal to total current into I5 means 6. We will write numerator 12. 12 divided by 12 plus 6 is equal to total current is equal to 2 is equal to 12 by 18 equal to 2 3. So we are getting 4 by 3 ampere. So this point is over. We have got the current as 1 ampere, and in second one 2 ampere, and next one 2 by 3 ampere, next one 4 by 3 ampere. So it is over. Now last question is voltage loss. So due to the presence of internal resistance, always there is loss of voltage. Now what is the total voltage loss? Voltage loss is this. We require to find out. So total voltage loss, the formula is total current into resistance of the specific resistor. So if you find out AB, so what is AB? AB, the total current is actually, we have written here 2, and what is the equivalent resistance? 1 by 4, 1 by 4. I have effaced out. That is 4 into 4 divided by 4 plus 4. Am I right? That was the answer. It was 2 ohm. So it is 2 equal to 4 volt. Am I right? So into BC, total current into resistance 1 equal to 2 volt. Into CD, potential loss into CD, in CD it is 6 into 12 divided by 6 plus 12. That was this much. I have effaced out. So this into 4 equal to 8 volt. Now what is the loss? What is total loss? Total loss equal to 4 plus 2 plus 8 is equal to 14 volt. And what is the EMF of the cell was 16. So net loss is equal to 16 volt minus 14 volt equal to 12 volt. This is the voltage loss due to internal resistance. Hope you have followed the class minutely. Thanks for a lot for watching the class, and please don't forget to subscribe the class to get updated.